So this is intro to GitLab. I called it DevOps on a shell script budget because my company is a fairly small organization, and GitLab is pretty cool for setting up, taking advantage of DevOps workflows on a small budget with not a lot of resources. My name is Mac Justice. You can find me on wherever you have usernames at Mac Justice. I've heard most of the jokes about my name, but if you want to come try, you're welcome to. I did actually get a new one a few months ago. Somebody suggested Chris Daw suggested I do my name in all caps and suggest that's my given name is capital MAC. I work for a company called Synapse. We're a product development engineering company in Seattle. A form of engineering consulting for a lot of big companies. Don't always know how to move quickly, develop products from scratch, and put them into production. You'd actually be really surprised what companies don't actually know how to do that well. Greatest hits that we've worked on that aren't NDA are like the Nike Fuel Band and a big old machine we made for the Gates Foundation to dig up latrines. That was a fun project, a lot of good testing. So I'm going to break this into two parts. First, we're going to do an overview of what GitLab is as a product, and then I'm going to talk about how I use it in my organization. So first, what is GitLab? It's a web app, just that. The core feature is hosting Git repos. If you've ever used GitHub, you kind of know the gist of it. It's a website you go to, you can clone your repos from it, you can push things back. It's a lot of the same stuff as GitHub. It's entirely open source, like they're radically open source. Everything about the development of the application is done in the open. You can go see the developer conversations, you can see their issues, you can contribute if you want to. It's all completely open source. And it's developed on GitLab.com via GitLab. So they're kind of dog-fooding pretty hard. Speaking of GitLab.com, you can get an account there. Accounts are free, just like with GitHub. And you can host repos, etc., like that. But where I think it really shines and where it's probably most popular is in the self-hosted area. I saw somewhere, I don't quite know what their sources on this is, but that they're the number one, they have the largest market share of any self-hosted Git tool. Which, well, maybe, but good numbers. They operate on a freemium model, so they have a really capable free tiers for their service, but you can pay a little more to get more features, etc., etc. It's also crazy frequently updated. Again, with the developing out in the open, they do a significant feature release on the 22nd of every month, and they do 4, 5, 6 patch releases in the meantime. So they are always cranking, and they give amazing update notes. You can see just literally every little, if you file an issue, you'll see the exact commit that it's fixed on. It's pretty cool. So here's a quick tour of the high-level features. Just like GitHub, this is kind of like the main view for a project. You got your folders of all your Git files that you're tracking. You can browse and edit in the browser, again, like GitHub. One thing that's kind of interesting I want to talk about is in GitLab, they use this concept called projects, and the project is kind of the top-level object. So within a project, you have your Git repository, you have your issues, etc., all these other things I'm going to talk about, but most things exist in these project containers. And they don't have to have a Git repo associated with them, so you can do other stuff in them besides just Git. They can host a wiki in it, you can do whatever. So again, like GitHub, you got merge requests. So you branch your repo, submit a merge request, goes into production. The whole team can go check it out, and you can explain yourself what you're trying to do. If you have conflicts, you can resolve them in the browser also. That's pretty nice. It's got a built-in issue tracker. I think this is really cool. So if you ever used like Jira or Fogbugs or something like that, it's got, you can submit it. It's kind of like a ticket system of sorts. And you can attach these issues to commits or CI builds or merge requests or just free flow. So whenever you're like, I've noticed this thing, just submit an issue, and maybe you can say, okay, well, this is the thing that broke it. You can assign them to team members. You can do time estimates on them. They even have like burn down charts and stuff. So if you get it, it'll give you an estimate of how much time it'll take for you to clear all your issues. It's pretty neat. With issues, you also get this nice issue board view. If anybody's ever used Trello, this will look pretty familiar, or any kind of Kanban system. It's helpful for kind of sprints and agile development type stuff. But one of my personal favorite features is the CI pipeline tool. So if anybody's ever used Jenkins or any other similar CI tools, it's their take on it. I'll be talking about that a little more later in the presentation when I talk about how I use it. And kind of just for fun, because it's the cool hip thing to be doing these days, there's also a container registry. So if you want to create and store your own Docker containers, you can push them right up into GitLab. Again, there's kind of a funny thing with this where they are stored on a per project basis. So it can get a little goofy when you're trying to share them cross projects, but like it's not that big of a deal. So how do you get one? At Synapse, we host GitLab on an Ubuntu VM, our VMware cluster, and most of the common Linux flavors are supported. They have a really nice package that's super easy to install. I mean, it's literally, you add their apt repository on Ubuntu, you add their apt repository, you apt-get install, you're pretty much 90% there. You do a little bit of configuration to get your host name up and all that, and you're done. It can also run out of Docker container. They generate those for use. And what I actually found I really liked when I was playing around, both for this presentation and just generally, is both AWS and DigitalOcean, and maybe others, I don't know, have pre-built GitLab instances that you can just fire up in minutes. Especially the GitLab one, or the DigitalOcean instance, I found really cool, because you can, you basically trigger it, it comes up, you log in, it says, hey, cool, do you want to set up Let's Encrypt? You'd say yes, you do it, you're there, you're live. It's really cool. And they even say, and they even compile it for ARM architecture, so you can run it on a Raspberry Pi if you really want to be lightweight. You can get away with that. The self-hosted pricing is really nice. There's 3 tiers: Community, Enterprise Starter, and Enterprise Premium. We were using Community up until like last fall, when we just decided, like, we've been using this for 5 years. Let's give them a little money. And it unlocks a few more finer grain permissions control. So you get to add, like, for example, merge requests. You don't actually have any approval. You can just merge in. This way you can make it so you have a certain amount, like a certain person is required to approve merge requests, or like a certain amount of people are required. So if you're on a team of like 3 people, you can say, all right, at least one other person has to sign off on this besides me. You just have something like that. And Enterprise Premium is kind of the big dog. You get real good support and lots of advanced features. Like, they've been developing like high availability stuff. A lot of options with that. But like I said, Community is really, especially if you're a smaller org, all you'll need. And it's free, so that's pretty cool. And they frequently push features that have matured in Premium and Starter down into Community, so you're not left in the dust. You're not running crippleware. So for user authentication and authorization, support LDAP, OAuth, SAML, Kerberos, and like more than I cared to put on the slide. Like, there was authentication methods that I haven't even heard of in there. At Synapse, we use G Suite SAML for employee login, and then we cross-reference that with LDAP for group permissions. We populate groups through the API, and then when you log into GitLab, it goes, oh, you belong to this group, here's your permissions, you're set. Since we're a consulting company, we also have to let our customers in to get access. So we let them access through Google OAuth. We just say, set up a Google account or a GitHub account. That's right, we use GitHub OAuth too. And go here, click the button, you're in. One of the neat things about their user control system is you can define a certain kind of users as external. So for example, you can say everybody who comes in through Google OAuth, call them an external user. And external users are automatically whitelist only. They get no access to anything until you say so. And that's really nice, since we're, again, like a company that's very concerned about NDAs and client privacy. Like, we don't want somebody from one company coming in and accidentally seeing something from the other company. So it gives a lot of assurance on that. There's a lot of integrations. Here's the chat ones. They also have their own alternative client or alternative tool called Mattermost that they bought. So you can set up Mattermost. Are you using it? Yeah, I know a handful of people using it. It's good? Yeah. Yeah.
It's a good replacement as well.
Okay.
Internal hosting.
Yeah. Yeah, exactly. If you need internally hosted chat, like if you say, come to the org and say, I'd like Slack, and they say, yeah, you're not dumping all our secrets out there, Mattermost is a great option. But like you see here, also HipChat, Slack, Teams, they're all available. And this is cool because you can set up notifications for different actions that happen in GitLab. Somebody assigns an issue to you, pops over to you, you get a ping about it, etc. Slack also has slash commands, so like you can submit issues out of Slack. So if you notice something's wrong, you just hit slash GitLab, new issue, the thing broke, And I think you can even assign from Slack, which is pretty cool too. If you're not interested and you're not required to use GitLab CI, you can use an external CI if you're already using it. Jenkins is pretty common, pretty popular. You can also use Atlassian Bamboo. And they also have just a hookup for a generic CI tool. I don't really know how that works, but maybe you built your own. I don't know. And this one's always interesting to me. I don't use Kubernetes myself, but I've been kind of interested. It seems like it's the hot new thing, right? And they've been spending a lot of resources making sure it's pretty closely integrated. GitLab, I think, because it is a web app, they're very, this is the flip side of dogfooding, right? Because they're a web app, they're very attuned to the needs of developing web apps. So they've built a lot so that it can like roll things automatically into a Kubernetes cluster. It's in production. It's magic. It goes over here. There's a staging one. There's a testing one. It's all over the place. It's pretty neat. I can't speak from experience, but sounds cool. So that's the general overview. Now I'm going to show you how I use it. And I'm going to do a little history to explain how. So when I started at Synapse, they were already using Git. They do a lot of embedded Linux work, so they were already pretty familiar with it. But some years ago, as the company got bigger, they realized we can't just all have our own individual things, or I don't even think GitHub was around yet. So they were looking into central repo hosts and internally hosted again because of client secrecy stuff. The first thing they tried was GitLite, which is still available. You can still use it. It's a free and open source tool. It gets the job done, not a lot of frills. I mean, it literally doesn't have a GUI. So it's literally just, you set up GitLite on a server. It's kind of like if you set up a bare Git instance on any server like you can, but you get some access control. So like, that's pretty neat, right? Around 2012, we were getting bigger. We needed a better tool. They wanted better collaboration, so they can, like merge requests. They can see what's actually going on. They wanted customers to be able to check it out without just giving them access to our internal GitLite server. They wanted a web UI so the PMs could get in there and like look at what's going on. So we looked at the market, and honestly, our selection criteria was not super rigorous. We picked GitLab basically because it was free and easy to set up. And the guy who was doing the picking was he's a Rails developer, so he was like, "What's on Rails? Cool, I want that." In the following years, I had set up Munki and was interested in getting my repo in Git. You've probably seen some talks here over the years about keeping a Munki repo in Git if you're familiar, and I kind of wanted to join that. It seemed like it had a lot of great benefits. If you're not familiar with how Munki's structured, the primary files you'll find in Munki repo are a bunch of plists and a bunch of packages. Plists go great in Git because they're just text. Packages, not so much. Git doesn't like big files. I think Rick was saying the hashing tool they use just isn't fast enough for large binaries, and so when it does all the comparisons, it's too slow. LFS. Anyhow, Git doesn't like that. So, knowing that, this was my first GitLab Munki system. It wasn't great. It got me somewhere. So here's some problems I had. It was very manual. So I'll walk you through real quick. So that's me. That's GitLab. That's our Munki server. That's the client. When I made changes, I'd push it to GitLab. But I'd only push the plists, your manifests, your catalogs, and I was doing catalogs, so I wasn't very smart then. Package info, all that stuff. So I'd push that up to GitLab. Step 2, SSH to the Munki server. Step 3, pull down from GitLab. Also, rsync from my local machine the packages to the Munki server. And if everything goes right, fingers crossed, clients get their packages. Where this breaks is if more than one person is trying to help. Suddenly, I push to GitLab. I was just about to SSH in, but an employee walked up and had a question, so I go off to their desk. Some other guy's like, "Oh man, I heard Max in about that thing. Maybe I'll go help out." And next thing you know, he's got, he hasn't checked in GitLab for 3 months, and he forgot to rsync his packages first back down, so he's running way behind. So he rsyncs back up, and there's just conflicts everywhere. It was bad. It was okay. Things were tracked, but it had problems. So I'm going to do a quick little interlude about Git LFS. So other people wanted to track big files with Git too. So a couple other projects were made. 2 notable ones that you see around are Git Fat and Git Annex, which were fine. I had looked into them a little bit, but they seemed kind of hard to set up, and especially since I had this old version of GitLab and I was going to set up another, this Git Fat and somehow integrate them, it just seemed like a lot of work. In 2015, GitHub announced Git LFS, which was going to be their solution to large file storage, as it stands for. And then, within months, GitLab announced they would be supporting it. And then I think months later, they had implemented it. So, again, Git does not like big files. Makes it real sad. Git LFS loves them. And so here's a rough sketch of how that works. I literally just kind of copied the LFS thing and kind of did my own thing with it. So the bottom there you have your local Git repo. The top round rect is the server Git repo, and then off to the side there's your LFS store. So imagine the server Git repo and the LFS store both live on the GitLab server. When you go to push to your server Git repo, it creates, what do you call those? Like semaphore files for your binaries. Meanwhile, it stores them off over here. That way, it can track them just as Git does. It goes, these are just some simple little text files, and all they do is contain basically a hash of the file to go get when you request it. So when you have Git LFS installed on your local machine, you say git pull, it goes, oh, you want some of these LFS files, let me go over here and get those for you with your order. It's pretty nice. It can handle some pretty big files. I saw that GitHub supports LFS on their public stuff, but they limit you at 2 gigs, probably because they're super popular. I found that on my on the Synapse GitLab server, I haven't run into a file that's too big yet. The biggest I've had cause to use was a 7.7 gig El Capitan image, and it didn't make a peep. I mean, it took a little while to go back and forth, but it wasn't a problem. Installing it is super simple. You can install it with brew or Mac ports. And then once it's installed by your package manager of choice, or you can also just install the binary directly if you want. Once it's installed, you run git LFS install, and that modifies your global git config to add the git LFS filters. So if you want to use it for a particular repo, go to that repo. Then you say git LFS track and do some kind of pattern for what you want to track. In this case, I just said star package, anything ending in package. That modifies your git attributes file. Then if you add and commit the change to that attributes file, now LFS is up and working. For Munki, you just do basically package files, disk image files. I don't usually do icons just because they're not that big, but you can do whatever you want. Yeah, and then you're good. So now here's your everyday use. This is my favorite part about Git LFS, is that from this point on, you almost don't notice you have it installed. You don't have to give any special commands. You literally just interact with all the files in your repo just as you would with standard Git commands. So for example, I git add my sweet app, I commit it, I push it. That's all. No special commands, nothing. I tend to use MacAdmins for my day-to-day work. So what I do is, I make my changes in MacAdmin, open up my Git client, check all my changes, commit them, push it. It's done. Fork is my current favorite. Everybody uses that. Fork's a pretty neat little Git client. It's in beta. They're probably going to start asking for money sometime, but enjoy it while it lasts. So back to our story. Our GitLab hadn't gotten any attention for a few years. The guy that had originally set it up had departed, and everybody else had other things to deal with, and it was getting on okay. I got to say, for having it installed it from source and then modifying it to add our own authentication stuff, and then left it running for like 4 years, it did okay. Not 4 years, 3 years. But like I had heard in the meantime that they had added LFS support, and that really lit a fire under me, so to speak, to upgrade and take hold of it. And also they got the sweet new logo that wasn't kind of, so it's supposed to be a tanuki, and I don't know if that old logo, like I don't know what that was. I always thought it looked like a weird dog thing, which I guess tanukis kind of are, but it was a little scary looking. The new one's kind of sleek and cool looking. So the first thing I did once I got my GitLab all upgraded was rebuild my Munki workflow. So now it looks like this. It's pretty good. So the way this works is I make my changes, I push to GitLab. On my Munki server, I had a cron job that just would periodically pull from GitLab, and changes go into production. It was simple. Collaboration worked. My boss wouldn't accidentally, conflict with my packages and stuff like that. And this will get you by. There's not a lot of trouble with it. I mean, I'm sure for an org of our size, I'm sure you could run into some problems with like, your cron job breaking or doing unexpected things, but it's good enough for us. So real quick now, I'm going to drop into another interlude about GitLab CI and their approach. So there have been a couple talks about continuous integration. In software development, it pretty much means you push your code, it gets tested, you find out, does it work? Essentially, those CI tools are just a really simple kind of automation tool. It's when X happens, do Y. And when X happens, the X in this case is you put new code arrives on GitLab. So push code to GitLab, do something, tell me if it works or not. The difference between, there's this other concept, continuous deployment and delivery, and it's more of a concept than anything, because it's still just push, do something, report results. Deployment, I get these mixed up all the time. Deployment is, delivery is, it goes all the way up till near production, and then that last second you sign off and say, this is good, put it into production. Continuous deployment means when you hit commit, as long as it passes, when you hit push, as long as it passes all the tests, et cetera, goes into production. It's kind of nice. So where does that actually happen? What GitLab uses they call runners. So these are little agents that run on various machines. You can run them on most of the major operating systems. I primarily use Linux. I've been playing with a runner on Mac. It's a little bit tricky, but it gets the job done. And I've also poked a little bit about doing it on Windows, just for some various software tester engineers we're looking at, and it works. I never got a handle on it, but it seems to do okay. So once you get the runner installed, it waits for GitLab to assign it jobs. Installing it's super easy. You basically, you add the GitLab apt, again, on Ubuntu, that's what I'm most used to. You add their apt repository, you install it, you register it. Registering is super easy. You just say, GitLab runner register to what? You point it to your GitLab URL, it goes, cool, what's my token? You go into GitLab, you go to your project, there's a little field there that says, here's your runner token, throw that into the runner, and it's up and working. You go look at your project, and it's like, this runner is ready to go. Runners can be tagged, so you can say this is an Ubuntu box, or this box has, this tool installed. For example, if you're using a specific compiler or something like that, you might say, okay, if jobs need this kind of compiler, go run it on this box. And you can also share them or make them specific to projects. So you can say, this one only works for this project, nobody else touches it, this is all ours. Like, I got this Mac to run auto package, I don't need, your random job to like show up and occupy my time. Like, that's not what it's for. They can also run in sequence or in parallel. So if you have a multi-step build process, and some of those steps can happen at the same time, they might go to multiple runners, they might just be, run two at the same time in the same runner. Got a lot of options. It also supports Docker. I think this is one of the coolest parts. So you can configure a runner to run Docker, a lot of running. And then you can specify what kind of container image to use at build time. So this is really nice because, like, for example, if I'm doing a project that needs Munki present or needs Python present, you can just say, go use the Python container, and it'll pull it out of Docker Hub, and there you go. You can use your own containers. It's great. There's one that I make a lot of use of that is contains all the AWS command line tools. And so like I just, pull that thing down, I pass my keys into it, it does AWS stuff, goes away. That's the cool part about Docker containers is you get a nice, fresh, clean environment every single time. You know exactly what's in it, and it's disposed of when it's done. It doesn't take up any more resources. GitLab Runner also has an auto scale mode, which I've just started playing with. It's really cool. It uses Docker machine to create temporary VMs in some kind of cloud provider or other hypervisor. So, for example, you just have this little runner box, and it's sitting there waiting for jobs. And say you have it set up to talk to AWS. And it'll say, you can set it up to have a certain amount of idle machines waiting. In our case, we just do one because we really don't do that many at a time. But the idea is, as soon as it gets a job, it'll throw up on that idle AWS instance, and then it'll actually start preparing a second one just in case another job shows up. So that first AWS instance is doing the process on the job, the second one's getting set up. That way, if another job shows up, it can hit that second one also, and so on. That sounds like that can get really expensive really quick, and it probably could. But they add nice limits that say, okay, top out at this amount, don't do more than this many at a time, et cetera, et cetera. You can also do it on, we were trying to do it on our internal VMware vSphere infrastructure, and I was getting there. Didn't quite do it, but like AWS was a lot easier to set up, so I've been playing with that. It also supports Azure and DigitalOcean and Rackspace and almost anything you can think of. And then, so yeah, then when the VM finishes the job, it gets shut down and terminated, thrown away. So each task you include in CI is called a job, and more than one job makes a pipeline. You get to define what order they go in, what they depend on, whether they can be sequential or parallel, and then you can also say fail conditions. So you can make it so, like in this case, it's currently working on the production step. Build succeeded, tests succeeded, staging succeeded. You can make it so maybe test one, nothing goes past test one. If it fails test one, stop. But maybe test two is just kind of like a check for the loose ends, and like maybe it's still okay, but you want to like you can set it up to be test two is like alert me, but let the process move forward. There's a lot of flexibility you can do with pipelines. And how do you see how things went? So back in the GitLab web view, it just punches out the logs. You can see the execution transcript of every job you do. That way, if I find myself doing a lot of when I'm troubleshooting CI and trying to build a CI framework, you hit push, you go open this thing up, you see the transcript, you go, that was dumb, should change the permissions on that. Go back, change it, you hit push, back around. Also for when something breaks or something fails, it's where you go check on things. So my favorite part about GitLab CI is that you define all your jobs as code in the repository. If you go on actually GitLab.com, you can play with this. Just by adding a file titled .gitlab-ci.yaml, GitLab will attempt to start executing it. If you use the GitLab.com, they use a public auto-scaling shared executor. So anything that I think executes in a Linux environment, you can already do on the GitLab.com public executor. And so what's great about this is, as you change your build process, it's tracked in Git alongside the rest of your code. And like that's pretty cool, because sometimes who broke the build is because somebody misconfigured something in the actual whatever you're trying to build. Sometimes it's you change the builds and that broke. So this way you can catch it both ways. So here's an example. I'm gonna walk you through real quick. So it's 2 steps. We got a validate one and a deploy one. I define each as a stage. GitLab has some preset stage terms you can use. So this one, if you just say test, they'll say test has to run before deploy. Second one says deploy, it'll run later, only after all tests have complete. You specify what script you want to run or other command. In this case, run lint roller on the first one. You can also specify what branches you want to run it against. So you can say only or accept, stuff like that. So this is great for if you want to do like, testing, production, staging, environment type stuff. You can say, all right, all branches that start with dev go here, all branches, master goes here, anything else goes over in this direction, and you can play around with it on your own. You can also pass variables into it. You can either define your own, or there's a lot that are set in the CI environment. So you can whatever path you're in, what executor's running it, et cetera, et cetera. So you can do a lot of introspection that way. Yeah, and then you can just execute whatever arbitrary amount of scripts you want. So you can call scripts, you can do inline bash commands if that's the environment you're working in. A lot of Docker stuff uses Alpine, which is a neat little tiny Linux thing, and I was having a real trouble with this the other day. I was trying to set up a new build, and I realized that I was running everything against a bang bash at the top of my script, and in Alpine, it doesn't have bash. It has a much smaller shell called ash, and just by changing that one letter, everything worked. It was great. Yeah, things you find out. And it kept on saying like script's not there. I'm like, no, the script's right there. You're looking at it. It turns out they meant shell isn't there. Yeah. Yeah. So both jobs succeed. GitLab report success. You can go back and hit you in Slack or send an email or whatever you want. You can even call like webhooks and stuff. So if you want to have it spit out an API or something, you can do that. It also has the concept of secret variables. So you don't want to put, it's been said a lot of times, don't put secret information in Git, like your private keys, API tokens. This is because it's really hard to get it back out, and like you don't know who's going to accidentally get access to this. You want to keep that stuff all separate. So GitLab CI has this cool thing called secret variables. So you store these things outside the Git repo, still in the project, but outside the Git repo, and then they're passed as an environment variables into the CI environment. This is really neat because, yeah, you can throw your deploy key, your Amazon keys in there, and it'll have it at runtime, but any other time won't have access. You can also, I don't think it says, yeah, protected. You can also say protected, so they will only run on protected branches. Typically, master is a protected branch. That way, only people with access to the master branch will even be able to see what they're going to be. Like, they can't go into the CI execution transcript and say, hey, could you echo that deploy key, please, and go read it. If you protect your variables, as long as nobody you don't trust is in master, you're good. So, you're ready to be taught the new way. Anybody White Hot fan? Kind of good. Okay, somebody. To the cloud. So now I know about CI. And I also figured out it was dumb to keep catalog files in Git. It's really dumb because they just change constantly, and it's like, you just changed 4 files, and there's like 600 lines that are changed. And you're like, I guess, just add and commit, sure. So I started doing the make catalogs on the runner side, and at the same time, I had seen Wade Robson's talk on hosting Munki out of S3, and started doing that. I recommend it. It's was at Mac DevOps Vancouver 2016. Was also referenced in Rick Heil's talk. That was the one previous to this one. Check them out. It's pretty cool stuff. Yeah, so this is my new workflow. It was really nice. Again, I just pushed to the thing. GitLab throws over to the runner. Runner does a couple things. I've started adding tests slowly, like checking what various package info files have, like making sure they don't have anything like placeholder or something like that. And then dumping it out to S3. It's pretty great. Takes a few minutes longer going through the CI process, but like it's so automated that like you just fire and forget, and you don't have to think about it. So from there, I was kind of off to the races. Started like, what else can I throw in here? Does anybody use Imagr? Couple, yeah. So Imagr is great because I just threw that whole dang disk image into GitLab or into Git LFS. It didn't care. It was like, yeah, give me 5 gigs, 8 gigs, I don't care. And track my Imagr config plist in there also. That way, when I make any changes to my Imagr config, I've set it up the CI, so it then does a couple checks, does the validates plist thing that Graham includes in it, and then if it passes a couple checks, it'll spit it out to our various site imaging servers. Again, really nice to update a OS. It's roll a new one in auto package, throw the disk image in there, change the references in the plist, and hit commit, and you're done. It's really nice. I've also experimented with signing configuration profiles. So I was digging into figuring out how to use. I was doing the thing where you get a new Mac, then you realize you left your keys and your signing keys on the old Mac. And you're like setting this all up again, going back through iTunes or the Apple developer stuff portal. It's not a lot of fun. I was like, what if I could just make a box that has the keys on it for the team, and it can just do all the signing for me. I don't have to worry about what computer I'm on or whatever. I'll just modify the configuration profiles, and it will take them and sign them. The other nice thing is configuration profiles are also just plain text. They're plists. And oh man, that was the other good one. Is I added a test to validate the contents of some of the fields, because there were an embarrassing incident or two where I had sent out profiles that had your org here as the organization, and so I got a couple questions about that. About like, is this legit? Should I be getting profiles from your org? Yeah. So my next plan is to figure out how to then add another step that will then take the signed profiles and throw them back into my Munki repo, which will then trigger that CI and all that fun. So got a couple ideas for where to go from here. I haven't built these out yet, but I've been watching other people and learning from them. Any guesses for this one? Yeah, they need a Nikon, right? Yeah, so auto package. And auto packages are good use for CI. I haven't implemented it myself, but again, if you saw, go watch Rick's video when it gets posted. He put together a really cool thing using a script from the Facebook CPE team to automatically populate stuff from auto package and throw it into your Munki repo. It's pretty cool. Then you get like a nice creates a separate branch for every updated app, and then you just go look at it and go, cool, merge it in, it's in production. It's very nice. Synapse is really trying to be an Ansible shop. I mean, we want to, we're getting there. And I'm planning to accelerate this by doing our Ansible playbook runs through CI. And what's nice about that is, again, you throw all your keys into secret variables, and they're kept safely there. You make your changes to the playbooks, they get thrown out. Oh, I forgot to mention earlier. So GitLab CI generally executes when you push to GitLab. They've added in the last couple versions, again, they update real fast. They got a lot of requests for adding scheduled jobs, so they now allow just basic cron style scheduling. You just type in a cron job time schedule thing, and it'll start executing on that schedule. I also learned about this yesterday. Wes over here created a thing called Mookins. It's an integration between Munki Umnipsa, which is an inventory tool, and Jenkins. So Jenkins queries the hardware inventory to know who has which computer, and then poof, suddenly users have manifests that follow them from computer to computer. It's pretty sweet. I took a look at that and I said, I can do that. I'm not going to do it on Jenkins, and I might not have Umnitsa, but like, the concept is sound. So why do I do all this? It's automatic. When everything's automatic, you save yourself a lot of time, and also you just like make the quality of your work that much better. You solve the problem once, we've all, and it goes. Also, I'm not spending a lot of time just moving things around, missing keystrokes, all these sorts of things. You set up the environment, let it go. It's accountable. You get to see exactly who's changed what, who changed it when, and also, like, because of the CI transcriptions, you get to see exactly what went wrong, which is great. It's not just like somebody calls up and says, oh, my thing's busted. It's like, oh, thankfully, we caught it before then. And Joel broke it. Speaking of, it's also collaborative. I definitely remember, like I was saying in my first iteration of Git and Munki, like, you have that problem of, hey, did you just make a change? Who's on the server right now? And like, you hate doing that thing where you have to, you're sitting looking over your shoulder like, is anybody gonna show? Is that you? By routing it all through GitLab, like, gives us a lot of visibility for who's doing what, and it makes it a lot easier for us to work together, break a problem into parts, and like bring it back into a whole seamlessly. Yeah. So that's it. I reference all these talks. Oh, I didn't really talk about Tom's. Tom, you talked about GitLab a little bit. Tom is he's actually running out of GitLab.com on free accounts. I'm kind of amazed. It's so and you're how many clients?
That particular server has. I guess should I be talking into a
All three of the box. Ooh.
Okay. We're in early testing, but again, we're rolling out. I think we've got 25 manifests out there to start, so 25 machines, and that will probably go up by a factor of 10 in the next 3 months.
And what's your GitLab bill like?
Pretty light. It's $0 right now.
$0.
$0 is kind of what I like.
Yeah.
I mean, but again, the only thing that we're putting in source controller there are package info files and manifests, because the catalogs regen all the time. The packages don't matter. And I mean, because we're handling those to get them out into production a different way. We're using AWS to throw those out behind CloudFront. But at least our initial, transfer of the repo and our first client for the last 7 days, is 9 cents. So
right.
that's our S3 build right now. And when that eclipses like $9 in a month, I'll have to start worrying. But probably not for another factor of 10 after that.
Cool.
So,
Lucas Hall, also good talk to watch that kind of fills in a little more about this. Wes's talk yesterday was really great. I was taking notes furiously the whole time, and then went back to my room and kind of reconfigured my whole presentation. It's a really good talk. And then finally, again, I've referred several times to Rick's presentation this morning. He's done some really cool things. He's definitely shot out ahead as what you can do with this sort of thing. I got a lot of my ideas for all this from Wade Robson, again, with his Munki middleware, but also Tim Sutton on Jenkins CI back at MacDevOps 2016. He was talking about his various imaging and auto package and Munki integrations he built through Jenkins. What's really cool about CI is it almost doesn't matter what tool you use. The concept is what matters. And once you grasp the concept, you can port workflows around. Each tool has different pros and cons and quirks and etc. Costs. And GitLab's just the one I really have been enjoying working with. So thanks for coming, everybody. Questions?
So I'm going to ask a simple question because my environment's weird. What was your implementation timeline like for your first? I mean, obviously, adding additional runners is very, very straightforward. Mm-hmm. What was your timeline like to implement your first runner? How many hours was that for you internally?
Since we don't have a great Linux provisioning tool internally, I probably spent like 20 minutes just setting up an Ubuntu VM, just getting the networking and stuff right on it. But then installing the runner itself is like less than 5. So not a lot of time commitment.
And then debugging?
Oh, debugging takes forever. It runs great. It's just then your jobs are terrible.
Well, I mean,
it's your fault.
That's looking for the point. Is
I see.
It just, hey, was this a 40-hour project? Was this a 90-hour project? Was this like a long slog?
It wasn't a long slog. Honestly, I think we had moved over in. Man, we're not very good at time tracking at my work, and I like 3/4 of my job is help desk, so like it's very kind of on the margins. I would say maybe like. It took me, I want to say, a month or two, but again, at like 10 hours a week maybe. So, and part of that was just like me fooling around and me showing it to people and eventually trying to get buy-in, et cetera, et cetera. Yeah, it's not a huge endeavor. And I think now that there are several people running this way, you can get up and going a lot faster.
Hey, great talk. For Git LFS, I use GitFat, and whenever you do the GitFat pool on the server side, it takes the pointer to the LFS object that's on the storage, and it tries to restore it and put it back together. Whenever you have something like a Mac OS installer that's 8 gigs, it's awful, and it will just consume every single piece of memory that like given hardware has. Is Git LFS like that at all?
Not.
Have you noticed anything like that?
No, it's a real quick HTTP pull.
Yeah,
Just
but
redirects it.
does it restore back together, or I'm assuming maybe it doesn't do that at all?
No, it keeps like, from what I can tell, it just keeps a whole, like, so whenever you add a different version, it just keeps the whole dang thing in there. So it just says, do I want A, B, or C? Let's go grab B. Yeah.
Oh, might have to check that out. Cool.
Yeah. Okay, everybody. Thanks for coming. Hope you guys all enjoyed the conference. I know I did. Oh, and in particular, the Git channel on the MacAdmins Slack, I tend to hang out a lot in. Me and Rick, throw ideas back and forth. We've almost unofficially tried to rename it the GitLab channel because it's like 75% of conversations in there, but like, thanks.